operator. So if you have any operator, and if you are talking about operator, you can have some mathematical operation actually. And that mathematical operation can be physical operation. That mathematical operation can be only mathematical in nature. Okay. Maybe sometime these operators can directly associate it to some physical thing. Suppose we have, for example, suppose we are talking about momentum operator. So in a quantum mechanics, we can define momentum operator as minus IH cut del upon del x. Suppose this will just tell you how your momentum of particle can be calculated. So this is your momentum operator. So you have Hamiltonian operator. So you have Hamiltonian operator. That can be H, and this is nothing but you can have px square upon 2m, that is kinetic energy of a particle, and potential energy, and you have to again write it in form of operator. So px can be written in form of this. So this value is equal to minus h cut square upon 2m del square upon del x square plus potential energy Vx. So this will be some mathematical operator, and this Hamiltonian operator is associated to measurement of energy. So we will see each and everything when we will go into the postulates of quantum mechanics. I am just giving you some glimpse of operators, which kind of operators can be there. Suppose you have parity operator. So what parity will do? When you will operate on parity on some function psi x, and you can take parity operator by pi also. So you can operate on some psi x. What will happen? This x will convert it to minus x. So if you want to change the position from one point to the just negative of this inversion kind of a space inversion kind of thing, you can use this parity operator. So n number of operator you will encounter into the quantum mechanics, not one, not two, n number of operators. So what you have to do, have to first try to learn in the first section how we will write any operator as a form of matrix. So we can represent our operator as a matrix also. For example, let us assume operator A is defined, and when it will going to operate on some vector n, and obviously this operator will operate from the left on the kit, what you will get? Let's say you will get something n, let's say some value, and or let's say you will get n, and that value is equal to phi n plus 1. So what this operator will do? ये operator क्या कर रहा है? कोई explain कर सकते हो क्या?
सर n को nth plus 1 स्टेट में लेके
हाँ,
जा
तो
रहा है।
एक स्टेट से दूसरे स्टेट में ले जाने के लिए आप काम कर रहे हो, है ना? So सपोज कोई पार्टिकल आपका ग्राउंड स्टेट में है और आप उसको फर्स्ट एक्सेलरेटेड स्टेट में लेकर जा रहे हो. ऑब्वियसली ग्राउंड स्टेट क्या है, फर्स्ट एक्सेलरेटेड स्टेट क्या है, ये सब हम बात करेंगे वेरी डिटेल मैनर. बट just you have one level and you have another level, you just want to shift the particle from one level to another level. So this kind of thing can be represented, let's say this will be that operator. So thing is that you can create some operator with mathematics, you can create some operator with your choice of physical quantities. Now you can write this operator as a matrix as a matrix representation. So operators are something like a matrix representation. So let's try to go for matrix representation of this particular operator, some operator basically. So how you will define this particular matrix representation, है ना? और आजकल एग्जाम में कुछ इस तरह के भी क्वेश्चंस आने लगे हैं कि पहले आप उसे मैट्रिक्स फॉर्म में लिखो एंड देन यू कैन गो फॉर दिस टाइप ऑफ देन यू कैन गो फॉर एनालिसिस ऑफ द प्रॉब्लम. सो व्हाट इज दिस? लेट्स से, सो इफ वी हैव अ बेसिस वेक्टर, लेट्स से दिस इज phi 1, phi 2 up to phi m, and we have phi n. Suppose we have n number of vectors and which can treated as a basis vector. It may be orthogonal, it may not be orthogonal, depend on situation, depend on our mathematical need, whatever we have discussed into the last class. So what we have, phi 1, phi 2, phi m up to phi n. And suppose any operator A is defined. Obviously, if this operator A is defined, what we have to do? We have to represent. So we have to represent operator A in matrix representation. In matrix representation, in a basis of phi 1 up to phi m up to phi n. Okay. So in a basis of phi 1, phi m, so A will be represented as, what will be dimension of A? A will be always a square matrix. Okay.
M
So
cross
what will
n.
be dimension of A?
M cross n.
N cross n dimension. Okay. So you have to calculate each and every element. Are you getting my point? आपको क्या calculate करना होगा? Each and every element. So for operator A, the element A, M and N. इसको बताओ तो क्या कहेंगे? This will be M and N element, है ना? किस ऑपरेटर का? A ऑपरेटर का. किस फॉर्म में? मैट्रिक्स फॉर्म में. मैट्रिक्स क्या होगा? That will be N cross N matrix. So how you will go for this? So this value is phi M A phi N. Phi M A phi N. So A will be sandwich between phi M and phi N. A किसके किसके बीच में सैंडविच है? Phi m और phi n के बीच में सैंडविच है. So now you can represent this particular thing. Suppose I am writing A operator 2 1. How you will write it? कैसे लिखोगे?
Phi 2
Phi 2a.
Very
phi
good.
1.
Phi 2a phi 1. Okay. So you have to calculate each and every element of matrix via this method, and this is just a definition of matrix element of operator A. So let's try to straightforward go for one or two example, then we can easily use this particular thing. So suppose I define my operator A phi n is equal to n a naught phi n. सपोज एक ऐसा ऑपरेटर है जो a phi n पर ऑपरेट करके क्या दे रहा है? n a naught phi n. And we have phi m phi n is equal to delta mn. इसका क्या मतलब है? कैसा बेसिस है ये? ऑर्थोनॉर्मल बेसिस है. ये हमें दिया हुआ है. सो व्हाट वी हैव टू डू? रिप्रेजेंट ऑपरेटर A in basis of phi 1, phi 2, phi 3. हमें क्या करना है? इस ऑपरेटर को रिप्रेजेंट करना है phi 1, phi 2 और phi 3 के बेसिस में. So how many element you have to find? 9 element निकालना होगा, है ना? Yes or no?
Yes.
So yes, sir. That value, so we have to calculate A M N. इसका वैल्यू कैसे लिखें? Phi M A phi N. यही होगा ना? Now A will operate on phi N. What you will get?
N A naught.
Very good. So this will remain same because we have a relationship with ket with this operator. So I will keep my bra same. A will operate on N. That value is N A naught phi N. I can take N A naught outside because this is a scalar number. So you can write it either left or right. So I am writing something N A naught phi M phi N. ऐसे लिख सकते हैं ना? Yes or no?
Yes, sir.
Yes.
Sir.
Yes, sir.
And what will be this value?
Sir, the board is not visible downside.
The board is not visible. Okay. Now I think now your board is visible. Okay.
Yes, sir.
ठीक है. बताओ ये क्या है? What is this particular thing?
Delta
So this particular thing is delta M and N. Now this is very simple. Now can you tell me this thing will survive only when M is equal to N,
Yes, sir.
or other term will be 0?
Yes, sir.
Yes. So is that A11 will be survive?
Yes,
Yes,
sir.
sir. That will survive.
तो बताइए A11 क्या होगा?
And a not.
1A0. N के जगह पर 1 पुट करोगे ना?
Yes, sir.
आप देखो फिर से कर दे रहा है. A11 phi1 A phi1. अब N के जगह पर क्या पुट करेगा? 1 करेंगे ना? So
Yes,
you
sir.
will write
Yes, sir.
phi1 1 A0 phi1, और इसे लिख सकते 1 A0 phi1 phi1. दिखाई दे रहा है? फिर गायब हो गया. It's okay? ठीक है ना? And what is phi1 phi1?
1.
1. So this value is 1 A0. तो अब मैं यहां पर लिख रहा हूं, इस स्पेस का यूज कर रहा हूं. चलिए आप मुझे बताइए A11 क्या होगा?
A not.
A not.
A0. A12
Zero.
0. Very good. A13
Zero.
A21
0.
Zero.
A22
Two A not.
2A0. Very good. A23
Zero.
0. A33
Three A
3
not.
a not.
23 के बाद फिर क्या हो गया? A31
3 1. 0.
0. A32
0.
A33
3 a not.
0.
Sir,
ठीक है?
3 a not.
Sorry, A0 3A0. This value is what? 3A0. तो आप इस A मैट्रिक्स को कैसा मैट्रिक्स होगा? क्या ये डायगोनल मैट्रिक्स होगा या नहीं?
Diagonal.
diagonal matrix
डायगोनल मैट्रिक्स होगा जिसके एलिमेंट क्या होंगे? 1A0 0 0 0 2A0 0 0 0 3A0. ठीक है? So this is your A matrix. A matrix आपने रिप्रेजेंट किया किसकी बेसिस में?
basis vector
हाँ, बेसिस वेक्टर phi1 phi2 और phi3 phi m में, जिसके साथ A और phi m और phi n का रिलेशनशिप आपको पता है. नाउ लेट्स ट्राई टू गो फॉर अनदर प्रॉब्लम. ये तो बहुत ही सिंपल है. अब थोड़ा सा डिफरेंट प्रॉब्लम करने की कोशिश करते हैं. यहां तक क्लियर है ना?
Sir,
हम्म.
every operator can be represented in matrix form.
Yes, every operator can be represented in a matrix form if you have basis vector. If you but you have to write that operator in basis of some vector. ठीक है ना?
sir
Hmm.
the parity operator, momentum operator, Hamiltonian operator, they all are linear
They all can be represented. They all
Yes, sir.
can be represented.
they all are linear operator.
They all are linear operators. Yes.
Thank you, sir.
चलो नेक्स्ट क्वेश्चन देखते हैं और इसे करने की कोशिश करते हैं, है ना? सो सपोज आई हैव a operator and which will define on phi n that will give you n a naught phi n plus 1. क्या है? phi n will operate on phi n. क्या दे रहा है? n a naught दे रहा है और स्टेट को कहां लेकर के जा रहा है? n plus 1 पर लेकर जा रहा है. ठीक है? Where n can be given as 1 2 3 up to infinity तक जा सकता है. ओके, डोंट वरी. सो इट मे बी इनफिनाइट डायमेंशनल ऑपरेटर, है ना? इसको हम इनफिनाइट डायमेंशनल ऑपरेटर भी कर सकते हैं. बट इट इज ऑल्सो गिवन phi n is equal to what? Delta mn. तो इसका मतलब क्या है? They are what? Orthonormal basis. ऑर्थोनॉर्मल बेसिस, ये सारा दिया हुआ है ना. ऑर्थोनॉर्मल बेसिस इज वेरी इंपॉर्टेंट थिंग फॉर योर क्वांटम मैकेनिकल ऑपरेटर्स, है ना. नाउ व्हाट यू हैव टू डू, यू हैव टू रिप्रेजेंट ए ऑपरेटर इन अ बेसिस ऑफ 1 2 3 एंड सो ऑन. ठीक है, ए ऑपरेटर को सारे के बेसिस में हमें लिखने की कोशिश करनी है. सो लेट अस ट्राई टू राइट दिस थिंग. लिखें क्या? सो व्हाट विल बी ए एम एन? Phi m a phi n. Yes, a will operate on phi n. What you will get?
n plus 1.
Hmm?
N a naught phi n plus 1.
So first you will write phi m n a naught phi n plus 1. You can take n a naught common. ले सकते ना? हाँ या ना?
Yes, sir.
बाहर ले सकते हो. So that will be n a naught. So this is phi m phi n plus 1. इसे क्या लिख सकते हैं?
Delta
सोच करके बताओ.
Delta m delta n plus 1.
So that is n a naught और डेल्टा m तो m ही रहेगा, n की जगह पर क्या आ जाएगा?
plus
n plus 1. ठीक है. नाउ आपसे मेरा क्वेश्चन है, क्या ये डायगोनल मैट्रिक्स होगा? से यस या नो?
नहीं.
नहीं होगा सर.
no, sir.
नहीं होगा, डायगोनल मैट्रिक्स नहीं होगा. तो मैट्रिक्स का कैसा होगा देखने में, वो हम जरा देखने की कोशिश करते हैं. ठीक है, लेट्स ट्राई टू डू. नाउ इस तरह के प्रॉब्लम को आप कुछ ऐसे भी कर सकते हो. व्हाट यू विल डू, यू विल राइट समथिंग लाइक दिस एंड हियर वी हैव phi 1 phi 2 phi 3. यू कैन अगेन गो फॉर phi 4 अप टू आगे तक जा सकते हो, है ना. जिस ऑर्डर में आपने किट लिखा यहां पर, उसी ऑर्डर में आप क्या लिखोगे? ब्रा भी लिखोगे. यहां पर आपने ऑपरेटर लिखा. ठीक है, और मैं एक एक एलिमेंट निकाल सकता हूं. नाउ व्हाट विल बी दिस एलिमेंट? ये पहला एलिमेंट क्या होगा जरा बता सकते हो?
0.
0.
नहीं नहीं उसको नोटेशन टर्म में क्या होगा? A11, है ना.
हाँ A1.
Yes, sir.
दैट इज व्हाट? A11. और A11 हम अगर कैलकुलेट करेंगे, जस्ट मैं अभी थोड़ा स्लो हूं, इसके बाद एकाएक फास्ट करेंगे. phi 1 A phi 1, दिस इज नथिंग बट व्हाट? A11. यहां तक क्लियर है ना? नाउ A विल ऑपरेट, अब देखो क्या है, phi 1 A phi 1, एक ब्रा लिए A phi 1. अब दूसरा एलिमेंट क्या लिखोगे? phi 1 A phi 2.
Phi 2. Okay.
So this element is phi 1 A phi 1. यही होगा ना? phi 1 A phi 1. दूसरा एलिमेंट क्या हो जाएगा? phi 1, this phi 1 A phi 2. उसी तरह से आपके सारे एलिमेंट बनते जाएंगे. चलिए अब हम जरा इसके मैट्रिक्स रिप्रेजेंटेशन को देखते हैं. A will operate on phi 1. What you will get?
0.
नहीं नहीं, अरे A will operate, पहले क्वेश्चन पढ़ो, मैं आंसर नहीं, आपका फाइनल नहीं पूछ रहा हूं. A will operate on phi 1. What you will get?
N a naught.
1
naught.
A naught phi 1.
A naught phi 2.
Phi 2.
1 A naught phi 2.
Phi 2.
And phi 2 and phi 1 is orthonormal,
Yes,
sorry, orthogonal.
Yes, sir.
Yes, sir.
So first term is what? 0.
0.
Okay. A will operate on phi 2. What you will get? Phi 3.
Yes, sir.
And phi 3 and phi 1 is orthogonal.
Orthogonal.
So this term is also
0.
0. A will operate on phi 3. What you will get?
Phi 4.
Phi 4. Phi 4 and phi 1 is
0.
orthogonal. So it is 0. So is that any chance that you are getting phi 1 here?
No.
No, sir.
No. So this will be 0. Infinite dimensional operator and you can get 0. Now, second point. Just come to this one. What will be this one? Phi 2 A phi 1. Isn't it? Now A will operate on phi 1. What you will get?
1 A
Phi
not
A
phi
phi.
1 A naught phi 2, isn't it?
Phi 2.
And phi 2 and phi 2 is
Orthonormal.
orthonormal.
One.
phi 2 and phi 2 is normalized. So that will be 1.
One.
So what will be this number?
A naught.
1 A naught.
Oh, A not.
Okay. Now A will operate on phi 2, phi 3, phi 3 and phi 2 is
Orthogonal.
Orthogonal 0.
very good. So is that any chance that you are getting phi 2 here? No.
No.
So all term will be
0.
चलो नेक्स्ट में कौन सा बचेगा ये बताओ. पहला वाला 0 होगा या बचेगा?
0.
0.
0.
ये वाला बचेगा या 0 होगा?
बचेगा.
बचेगा. A will operate on phi 2. What you will get? Phi 3.
Okay, phi 3.
So that will be 2 A naught, isn't it?
Yes, sir.
Yes. So that will be 0. Are you getting trend?
Yes, sir.
बताओ तीसरा वाला ये बचेगा या 0 होगा?
0.
0.
ये बचेगा या 0 होगा?
0.
अभी क्या होगा?
3 A not.
वेरी गुड. फिर से बताओ अगला वाला.
0.
0.
फिर
0.
फिर
0.
अगला वाला
4 A naught.
4 A naught. So you have this type of matrix, isn't it? And you can see this is nothing one dimension to. These are infinite dimensional matrix, isn't it? And this is something like a lower triangular matrix, isn't it? है ना? So you have only below the diagonal part is your matrix representation. Okay, let's go for one more problem. ठीक है? यहाँ तक clear है ना?
Yes, sir.
Okay. और ऐसा खूब हम करेंगे different टॉपिक्स में, different चैप्टर्स में. So we will do lot of practice. Just अभी आपको definition और मैथमेटिक्स इसकी समझना है, किस तरह से आप चीजों को निकाल रहे हो, है ना? So this is very interesting. Let's go for next one. चलिए. If I am representing my operator as A is equal to phi 1 phi 2 plus phi 1 sorry phi 2 sorry phi 1 plus phi 2 phi 1 very interesting plus phi 2 phi 2. Okay, suppose this is your operator. We have defined this particular operator. Okay, what you have to do? Represent operator A in basis of phi 1 and phi 2, which is orthonormal in nature. पहले ये बताओ कितने क्रॉस कितने का ऑपरेटर होगा ये?
2 cross 2.
2 क्रॉस 2, क्योंकि बेसिस वेक्टर हमारा क्या है? phi 1 and phi 2. So they are what? Orthonormal in nature. Okay. चलिए. So first element हमें निकालना है A11. क्या लिखेंगे? phi 1 A phi 1. यही लिखेंगे ना? Now, so from right side, from left side you will operate phi 1 and right side you have also operate phi 1. So क्या होगा? First element क्या हो जाएगा? phi 1, इधर से phi 1 आ गया, है ना? और इधर से क्या आ जाएगा? This phi 1. चलो पहले मैं फॉर्मूला लिख देता हूं. You can operated phi 1 here. Now I am writing A. So phi 1 phi 2, phi 1, phi 2, sorry, क्या लिखा है? phi 1 plus phi 2, phi 1 plus phi 2, phi 2, and here is phi 1. So now if I am going to open it, then what you will get? आप जरा देखोगे कैसे लिखाएगा ये? phi 1, phi 1, और लेफ्ट साइड राइट साइड से क्या आ रहा है?
Phi 2, phi 1.
That value is phi 2, phi 1. नेक्स्ट टर्म बताओ क्या होगा?
Phi 1, phi 1, phi 1.
So that value is phi 1, phi 1. इधर से क्या होगा? phi 1, phi 1, है ना? नेक्स्ट वैल्यू बताओ क्या होगा?
Phi 1,
Phi 2,
वेरी
phi 1,
गुड.
phi 2.
phi 1, phi 2, और फिर क्या होगा?
Phi 1, phi 1.
phi 1, phi 1. नेक्स्ट वैल्यू क्या हो जाएगा?
Phi 1, phi 2.
phi 1, phi 2, और
Phi 2, phi 1.
phi 2, phi 1. दिखाई दे रहा है ये? चलो, नाउ फर्स्ट टर्म
0.
0. Why 0?
Phi 2,
Because
phi
it
1.
is 0. Second term
1.
1. Third term
0.
0. Because this is 0. This is also 1. This term
0.
0. So what will survive here? 1.
1.
So
One
first
will-
element is what? 1. है ना? 2 क्रॉस 2 का होगा. So first element is 1. अब मैं 1 2 लिख रहा हूं. So मैं क्या करूं? यहां पर 2 लिख दूं ना? And I will write what? 2 here. So I will
Yes,
write
sir.
what? 2 here. ठीक है?
Hello, sir.
हाँ, hello.
Sir, can you explain the last step, sir?
हाँ, sorry.
Last step, sir.
चलो अभी वाला जो कर रहे हैं उसको देख लो. ठीक है?
Okay.
Okay. So I have written phi 1 here and I have written phi 2 here. Okay?
Yes, sir.
And this part is A. Are you agreed? This whole in the bracket part is A.
Yes,
Now
sir.
I am writing it again. Okay? So what is first term? Just tell me what is first term? Just tell me what is first term? Phi 1, phi 1,
Phi 2, phi 2.
phi 1, phi 1, phi 2, phi 2 plus what is second term?
Phi
Phi
1,
1, phi 1.
phi 1, phi 2.
Phi 1, phi 1, phi 1,
Phi 2.
phi 2. What is third term?
Phi 1, phi 2.
So you have phi 1, phi 2, phi 1, phi 2. Isn't it? What is last term? Phi 1, phi 2, phi 2, phi 2. So which term is going to survive?
First term.
1.
Only first term is going to survive. All other term is 0. So what is that value? That is 1. Okay? Are you comfortable? That girl who asked doubt right now?
Sir.
Are you comfortable?
Yes, sir.
Okay. Then calculate what will happen to phi 2, phi 1. फटाफट calculate करो.
1 is coming.
So which term is going to survive?
Third term.
Only third term is going to survive. Very good. So third term is going to survive. All other term is equal to what? 0. Because phi 2, 1, phi 1, 1. All other term is 0. Phi 2, phi 1 is 0. You can have phi 1, phi 2 is 0. And here phi 2, phi 1 is 0. So only this term is survive. So this term is also 1. Next, what will be phi 2, phi 2? Sorry, A22.
1.
Which term is going to survive?
Last term.
Last term is going to survive. So this matrix A is 1, 1, 1, 1. Okay. And this type of question is very much prominent into your JEST examination, TIFR examination, as well as your NET exam, GATE exam, not in JAM exam. So this is the advanced part for the JAM. So the people who are only trying to focus on JAM, they should leave this part. But yes, this is not so tough, isn't it? This is just a play, just a juggling type of thing, है ना? So you can just do practice some of the operators like this. Okay? कुछ पूछना है तो पूछिए. If you want to ask something, you can raise your question. Okay, so I am just going to discuss one very important operator that is known as what? Projection operator. Okay, that is known as what? Projection operator. And I will also discuss little bit of completeness relation. This is very important to understand quantum mechanics, but let's try to go for a projection operator and completeness relation. Now, what I want to do, suppose I have a vector psi, and I have another vector, and I am just representing due to analogy. So I have another vector that is basically, let's say, this vector is phi. What I want, I just want to take a projection of psi in a direction of phi. Are you people comfortable? मैं क्या करना चाह रहा हूं? I just want to take a projection of psi in a direction of phi. I just want to take this psi and project it in a direction of phi. So in which direction I want to project? Phi direction. So, and I have told you that whatever operation you want to do, you have to make a operator. Whatever thing you want to do in the quantum mechanics, you have to define operator. So here I will define a projector operator. Or projection operator. Projection operator. And we will make sure that this phi is basically normalized in nature. Okay, this phi is normalized. So we have projector operator P, which is defined as phi. This is phi and phi. This is your projector operator. Okay, so let's try to first go for a basic property of this particular projector operator. We will just go eigenvalue, eigenvector into next class, but currently we will just try to assume that these are normalized vector. Okay, so this is my projector or projection operator. What we will do, we will operate, we want to project psi in direction of phi. So what we will do, we will operate P on psi. Okay, and what is this P? This is your phi and psi. So phi will operate on psi. This will give you some number, isn't it? ये क्या होगा?
Del pi psi number.
No, this is not a orthonormal vector. It is not necessary they are orthonormal. So this will be some scalar number. This is nothing but what? A scalar product between phi and psi, isn't it?
Yes, sir.
Okay, I am not saying these are orthonormal. So this is just a scalar product between phi and psi. So I can write this value as some c. And now you can write p psi is equal to C phi. So in which direction you are getting your vector after the projection?
High direction.
In phi direction. So this will act as a projection operator. Okay. So this will act as a projection operator. Now let's try to go for a suppose.
Sir,
Huh.
sir, if we want phi's direction in direction of psi,
Hmm.
then we will take the projection as psi.
Of psi. Yes. Just we are doing this thing. Suppose you want to project phi in direction of psi. Okay. Then what you will do? You will make a new projection operator, and that value is basically psi and psi. And where you are going to operate it?
On phi.
On phi. So you will operate on phi. So this value is psi, psi, phi. And what is phi psi? Psi phi? This is just a scalar product, isn't it?
Yes, sir.
And this scalar product can be C star. Suppose phi psi is C, then this will be C star kind of thing, isn't it? If this is a complex number. So you can write this will be some C star because phi psi is C, and you can take in direction of psi. Yes. Now you can verify yourself also. What will be projection of phi on itself? Phi, same vector. हो गया नहीं?
Yes, sir.
Just listen very carefully. What I am saying, what will be projection of phi in a direction of phi? That will be same vector. So look
Yes,
at
sir.
here. So we are making the projection operator phi, phi. We just want to operate on phi. So that is phi, phi, and we are operating on phi. And this phi is equal to what? 1. So what you are getting? Same vector.
It would be if phi is normalized, na?
Yeah, phi must be normalized if you are using it as a projector operator. Okay.
Okay.
So phi must be normalized. You have to use this particular thing. Okay.
Matlab, when we are applying any projector operator on some function, then that should be normalized function.
Yes, that projector operator, the function or the state you are using for the projector operator must be normalized in nature. Okay.
Is the vector on which we are finding projection that one, or on which we are applying, or both?
No. On which vector you want to project? We are making projector operator with phi vector. So we have to make sure that whether it is normalized or not. Okay.
Sir, in same direction, P is also known as identity operator.
Sorry.
सर जब हम सेम डायरेक्शन पे प्रोजेक्शन लेंगे तो P को हम आइडेंटिटी ऑपरेटर भी बोल सकते हैं.
ऑब्वियसली अभी हम बात करेंगे जब मैं आइगन वैल्यू आइगन वेक्टर करूंगा तो आप देखोगे प्रोजेक्टर ऑपरेटर के आइगन वैल्यू आइदर 0 होंगे, है ना, या 1 होंगे. सो यू कैन यूज हियर. ठीक है. सो दिस कैन बी वन टाइप ऑफ आइडेंटिटी ऑपरेटर, वन सॉर्ट ऑफ समथिंग लाइक दिस, बट नॉट एग्जैक्टली आइडेंटिटी ऑपरेटर. ठीक है.
यस सर.
है ना. अभी आप देखोगे इसको. ठीक है. ओके. नाउ suppose you have two orthogonal vector, then what will be projector of one vector to the another one?
0.
0. So you can take it. Suppose you are making a projector operator of I, you are going to operate on J, and where you have phi I, phi J is equal to delta Ij. So what you will get? Phi I, and this value is what? Delta Ij. And delta Ij will be 1 only when I is equal to j. Otherwise, it will be always what? 0.
0.
है ना? So you can easily use this concept here. So it is very important. Clear है ये? Now let's go for this particular, and this projector operator is very important into quantum mechanics. Why this is important? Because it will just tell you all about the basis, how you can change the basis, how you can write each one vector in a basis of another linear combination of another. We will just discuss right now. So let's go for one of the very fundamental thing, that is completeness theorem. So should I move ahead?
Yes, sir.
है ना? So let's try to go for completeness theorem. So this class is, obviously I am again telling, this is little bit of advanced class, but obviously if you want to do quantum mechanics in a correct way, then obviously you have to focus on all this abstractness and all this mathematics. Okay? Everyone is comfortable? Chalo. Let's try to go for a completeness relation now.
सर एक मिनट,
हाँ।
पिछला जो हमने स्टेप किया उसमें हमने डेल्टा आई जे वो ऑर्थो नॉर्मल लिया हमने,
हाँ, ऑर्थोनॉर्मल वेक्टर था ना?
तो
अगर
सर
वेक्टर,
वो आपने कहा
अरे
वन
भाई आप क्वेश्चन पहले ध्यान से सुनो। मैंने ये कहा अगर फाई आई और फाई जे ऑर्थोनॉर्मल हैं और आप प्रोजेक्टर ऑपरेटर आई का बनाते हो, आपने प्रोजेक्टर ऑपरेटर किसका बनाया? आई का बनाया।
आई का,
और अगर ये फाई जे पर ऑपरेट होगा तो क्या देगा?
जीरो,
फाई आई और डेल्टा आई जे, यही तो देगा ना?
यस सर,
ये कब, ये जीरो कब होगा? जब आई इज नॉट इक्वल टू जे।
यस सर,
तो ऑब्वियसली, और आपको पता है ना कि किसी भी ऑर्थोगोनल वेक्टर को प्रोजेक्ट करोगे तो हमेशा क्या मिलेगा? जीरो।
यस सर,
So if two vectors are orthogonal, if I and j are orthogonal, then obviously what you will get? You will get zero. You will survive only when I is equal to j. है ना?
सर,
So I am just telling this story from this mathematics. Okay? And this is condition if, don't worry. If this is there, then you can write something like this. Okay? Now, let's try to go for a very interesting thing, that is completeness theorem. So suppose I have a basis phi 1, phi 2 up to phi n, and if phi 1, what is this thing? Projector operator, है ना? किसका? 1 का, प्लस phi 2, phi 1 प्लस phi 3, सॉरी क्या कर रहा हूं, phi 2, phi 3 up to phi n is equal to आइडेंटिटी ऑपरेटर। ये क्या हो जाएगा? आइडेंटिटी ऑपरेटर। ये सारे को अगर ऐड करोगे, एंड इफ यू आर गेटिंग आइडेंटिटी ऑपरेटर इन अनदर वे, व्हाट आई एम ट्राइंग टू से, P1 और Pi summation over I is equal to identity operator, then phi 1, phi 2 up to phi n will make complete basis. Will make complete basis. Are you getting my point?
So
This is
we have
what?
to represent projection.
Huh?
P represents some of the projections.
Projection of first, projection of second. You can write this thing at P1. This is P2. Next is P3 up to Pn. And this must be what? Identity operator. Then this will be treated as what? Projector operator. So this will be nature of completeness relation. And this will be known as completeness relation. Completeness relation. You can check whether your vector are useful or not in a quantum mechanics via this method. For example, let us go for this particular example. Phi 1 is equal to 1, 0. And phi 2 is equal to 0, 1. So we have to check whether they will make a complete basis or not. And why we are checking it and what will be the role of this particular thing, this will help you, okay, to write the one vector in a basis of another vector and mainly the orthonormal basis of another vector. And it will help you to make your thing very compact as well as very conceptual. Okay. So how we have to check? The first thing I have to write phi 1 plus what will be second one?
Phi 2,
Phi 2. What is phi 1? 1, 0. What is this one? Bra part. So I have to write something like this. Plus, what is phi 2?
0, 1.
0, 1. What is this one? 0, 1. What is this equivalent? Now, this is number of or matrix?
Matrix.
Matrix. So 1 into 1 is 1. 1 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. Plus, now look at here. What is going to happen? 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. What you will get? 1, 0, 0, 1. So this is what? Identity operator. So if it is identity operator, then your phi 1 and phi 2, if you are taking these two vector, they can make complete basis for your some two-dimensional vectors. Okay? This will make a complete basis. And what is meaning of this complete basis? We will learn when we will go for postulates of quantum mechanics in 1 or 2 days, after 1 or 2 days. Okay? Everyone is comfortable right now?
Sir, P represent projection of phi 1 on which basis? Means on phi 2.
What you are doing? I am just writing the projection operator phi 1. You can operate on any vector.
Okay, got it.
Okay, चलो एक और एग्जांपल लेकर देखते हैं. Let's try to go for 3x3 vector.
We are getting the identity as an operator, na? Identity.
As a matrix, yes. As an operator, as a matrix. Yes. Okay. Suppose, let's say 3x3 matrix. Phi 1 is equal to 1, 0, 0. Phi 2 is equal to 0, 1 by root 2, 1 by root 2. Phi 3 is equal to 0, 1 by root 2, minus 1 by root 2. Are you people happy right now? And then we have to check whether these three will make a projector or will complete basis or not, or will they all three will follow the completeness relation or not. So how you will go for? Phi 1 plus next is what? Phi 2 phi 2. Very good. Last is what? Phi 3, phi 3. What is phi 1? Get or bra? 1, 0, 0. And this will be 1, 0, 0. Okay. What is phi 2?
0, 1 by root
1
2,
by root 2, 1
1
by
by
root
root
2. And this value is equal to 0,
1 by root
1
2,
by root 2, 1 by
1
root
by
2. Same thing you have to write in a bra form. Next is what? 0, 1 by root 2, minus 1 by root 2. And here you will write 0, 1 by root 2, minus 1 by root 2. Yes? Now, what will be this matrix? So this is matrix or number?
Metric.
Matrix. So what will be this matrix?
1 and all are 0.
1 and all other are what? 0. है ना? 1 1 1 1 0 0 1 0 0. So you can use this thing. Next. So first term will be 0.
0.
The
0,
second. This one is 0.
Zero.
This one is
1 by
half.
2,
This one is
1 by
half.
2,
This one is 0. This one is
half,
half. This one is half.
half,
Plus. Let's go for this one.
0, 0,
This will be 0. Next.
0,
0,
1 by half,
1 by 2, minus 1 by 2. 0, minus 1 by 2. 1 by 2. Now you can check. What is this thing? Is that this is a identity?
Yes, sir.
Yes, sir.
Yes.
Yes.
1 0 0 0 1 0 0 0 1. Yes. This is a identity operator. Now my question is that what you will do with this particular projection operator? Look at here. This is the most important thing, that why we are taking this as this abstract notation and this abstract mathematics. Now, suppose I have psi operator, sorry, psi vector, and I have pi I is equal to I. What is meaning of that? ये क्या
Complete.
बता रहा है?
Complete projection.
They will make a complete basis. They will follow the completeness relation. Isn't it? They are just going to follow that completeness relation. So now, can I write I here and I will get same psi?
Yes, sir.
Identity operator को किसी भी वेक्टर पर ऑपरेट करोगे, what you will get?
Same
Same
vector.
vector.
Same vector. Now look at the magic, and this is real magic. Pi I psi. What is this thing?
number,
Phi
What is this thing? Projection
Projection.
of
Phi
psi
of
in direction of phi I.
Pi I.
And this will be what? Some number?
Yes.
Yes. So can I write something I like Ci phi I? What you have done? You have write your psi in an orthonormal basis of phi I. Isn't it? आपको याद होगा वेक्टर का कहानी. वेक्टर में यही तो करते थे. Look at. This psi is nothing but summation over I, phi I, psi, and phi I. Now you remember day 1 class? I have one vector, and this vector is A1 I cap, A2 J cap, A3 K cap. And what is A1? Can I
dot
write
A.
this thing as I dot A I
cap.
cap? And what is A2?
J
J dot A
A dot
J
A
cap.
J cap.
And what is A3?
K
A
dot
dot
A
A K cap.
K dot A
in the
in a
direction.
K cap. Isn't it? So same thing we have done it here. Are you getting my point? What is this particular thing? बताओ ये क्या है?
Projection of psi
In a direction of phi I.
phi I.
Phi.
What is this thing?
Of a nine.
Same thing. Projection of A in a direction of I cap. Isn't it? So now you can, if you have this particular thing, then you can easily write any state psi in a basis of phi 1, phi 2, phi 3, and phi n. And this is basically mother of all concept in quantum mechanics. Mother of all concept in quantum mechanics. So ultimate thing is, the actual thing is that how you are going to calculate this particular thing. Are you people comfortable? The real thing is whatever we are doing in a quantum mechanics, ultimately we have to land at this point. Ultimately we have to land at this point. And if you are getting this particular thing nicely, then obviously half of the work in the quantum mechanics have been done. The main idea of quantum mechanics is that you have n number of vectors, and these vectors can be right in a appropriate basis vector. Don't worry, just give me 2 days more. You will just think what we have to do in an actual sense, in a more natural sense of a quantum mechanics. Are you people comfortable right now?
Yes, sir.
Hannah? So we will take a small break, and after then, because I have to clean my board, and after then we will go for the second session of quantum mechanics. Okay?
Okay, sir.
Okay.
Okay, sir.
Sir,
Yes.
so otherwise, to write the states in the orthonormal basis, it will be difficult, no, sir?
Sorry.
Sir, to write the state in an orthonormal basis, otherwise, except this equation will be difficult, no, sir?
It is very difficult. It will be next to impossible. Okay?
Yes, sir.
Now, in an examination, what we will do, we will direct calculate this one. Are you getting my point? And this is
Yes,
nothing
sir.
but the scalar product between phi and psi. We know all this thing. But why we are calculating this one? Are you getting my point?
Yes, sir.
Because you can write psi as I into psi. And what is I? This I is this particular vector. So we will discuss it in a very deep manner when we will go for postulates. Don't worry. Okay. Right now, I am not going into very deep. I am just going to how we are doing the mathematics and all this thing.
You can say,
Okay.
no, this
Yes,
is
sir.
the component of psi in direction of phi. and
Exactly.
this is the component.
But look at. You are saying it is in a very natural way. It's a very good thing. But thing is that suppose I am just giving you a real challenge Suppose I have a vector known as xa minus x. And in actually, this algebraic function can be written as a Cn some phi n. And can you believe what will be this phi n? This phi n is nothing but root 2 upon a sine n pi x by a. We will see when we will go for the particle in box. Are you getting my point?
Yes, sir.
So, can anybody imagine that this algebraic function is nothing but the superposition of lot of sinusoidal wave?
Yes,
X minus x square.
Huh?
X minus x square is superposition of some sinusoidal wave.
Yes, you will surprise this about this thing. Are you getting my point?
Yes, sir.
And you will also surprise that this particular function will be just behave like as your this thing is nothing but this will obey this particular thing. So we have to always very much careful that what is this particular phi i's. We will neglect all other phi i's. In mathematically, you can get n number of vectors, but which vector is good for you to solve the quantum mechanical problem will actually, they must pass the litmus test of this completeness relationship.
yes, sir.
Okay. In general, it when you will become little bit more mature after 3 and 4 classes, then you will never remember this thing. But my question is that how you are getting this psi into this form? All the magic behind writing this psi in this form is basically this operation. Are you getting my point?
Like if we consider it physically, then we can say that every state, the combination of every state is giving us a unity, like one, है ना, identity. Every state, combination of every state is giving us one.
No. You are talking about this one?
So no, next step, that 5-1 projection we are taking na C1
Actually, no. Look at this function. Look at this function is written in a basis of this function. Okay.
Yes, sir.
First challenge is that what is this particular Cn? So okay, you can easily calculate from scalar product of this psi into this. Okay.
So yeah.
है ना?
Yes.
Okay. So these all things are coming from which mathematics? From this one. Na? If this is not correct, you cannot write something like this. Are you getting my point?
Yes, sir.
So I am just trying to explaining you that in general, everyone is writing this thing directly. But my question is that from which mathematical background you are writing this particular thing? Who is giving you authority to write this particular thing?
I equal to I psi.
Obviously, this thing is given me authority that I can write my psi something like this. Because this is nothing but identity operator. है ना?
आइडेंटिटी ऑपरेटर के थ्रू काफी कैलकुलेशन भी इजी पड़ जाता है.
बहुत इजी पड़ जाता है और चीजों को आप जब भी चाहो तो बेसिस चेंज कर सकते हो, एक बेसिस से दूसरे बेसिस में लेकर जा सकते हो, है ना?
सर.
एनीवे, सो बहुत ज्यादा अंदर नहीं जाते हैं. सो अभी अपने आप को थोड़ा रिस्ट्रिक्ट करते हैं, बट अपने आप को मैथमेटिक्स के बेसिस पर आप समझने की कोशिश कीजिए. ठीक है
सर?
Okay, sir.
If for any vector completeness relation doesn't hold, then it means in that basis we can't represent our vector. Na?
That will be very challenging. We cannot represent the thing which will be useful for you. Okay?
Okay.